If you spent any time working with Kubernetes, orchestrating applications, you probably know the feeling. That sort of meticulous dance with configuration files, stacks of YAML, and maybe that little bit of dread that, one typo could bring things crashing down. It's almost a rite of passage, isn't it?
Oh, absolutely. It really is. The amount of manual work, the sheer complexity of just managing Kubernetes resources, especially if you had like multi-component applications, it used to be a huge barrier, a real barrier to moving fast and being truly efficient, operationally speaking. Often felt like you were just, well, reinventing the wheel constantly.
Yeah, you've nailed it there. And that's exactly why we're doing this deep dive today. We want to cut through some of that complexity and really unpack a tool that's honestly fundamentally changed how we deploy on Kubernetes Helm.
hmm
And specifically, we're going to focus on Helm charts. They're the real heart of this package manager.
Yeah, think of a Helm chart as more than just a recipe. It's like a fully parameterized blueprint for your whole application. And it's version controlled too. It bundles up everything you need for deployment, gives you a standard, repeatable way to do things, and crucially, it lets you adapt to completely different environments with just, a few minor adjustments.
Okay, perfect. So let's unpack that. Our mission then for this deep dive is to really pull out the most important ideas about the three core concepts that make Helm charts so effective and, frankly, beginner-friendly too. We're talking values, templates, and the release lifecycle. By the end, you should really grasp how they work together, why they're so useful, the problems they actually solve, and, well, why they've become so essential in the Kubernetes world today. All right, so let's kick off with the why. Before Helm really became a thing, what were the biggest headaches, the main operational struggles developers and ops teams were dealing with? Because understanding that pain, I think, really puts Helm's impact into perspective.
Right. Before Helm, it really was kind of the wild west of YAML management. Teams had to manually write and then keep track of separate config files for every single Kubernetes thing, deployments, services, config maps, you name it. For anything reasonably complex, you could easily have dozens of these YAML files, and each one needed super careful handling. The chance of making a mistake was huge, and trying to find a typo across all those files, well, it was a nightmare.
Oh, I remember hearing about teams having YAML review parties, just trying to catch inconsistencies. And it wasn't just the number of files, was it? Customizing for different places like dev versus production, that must have been incredibly painful.
Absolutely painful. You were looking at manual find and replace across maybe 10, 20 files just to change, say, an image tag or replica count. It inevitably led to inconsistencies, configuration drift between environments. Pretty scary stuff, actually.
And what about dependencies? If your app needed a database, maybe a message queue.
Yeah, that was another major headache. Dependencies weren't just more YAML. Each dependency, like a database or a cache, often meant a completely separate deployment effort. Sometimes uncoordinated, often complex in its own right. It all just added up to massive friction in getting things deployed and updated.
Wow. Okay. And then say an upgrade goes wrong, or you just needed to roll back to a version that actually worked.
You were pretty much out of luck for an easy fix. You were doing like a manual deep dive into kubectl apply ref history, trying to piece together what the previous state was. There was no built-in way to track the version of the entire application stack as a single unit on the cluster,
Right.
or to easily revert it.
So, okay, that paints a clear picture of the challenges. How do Helm charts step in and, well, fix all that?
Fundamentally, Helm charts tackle these problems by packaging all those necessary Kubernetes configurations into one single coherent thing, a chart. This immediately takes configuration management from being this spread out, messy situation into something you can manage from one place.
Right. So instead of juggling, a whole folder full of separate YAMLs, you have this single self-contained chart package. That alone sounds like a huge win for organization.
It really is. And it's not just bundling. Charts allow you to customize deployments extensively without actually changing the core chart files themselves. This directly solves that problem of manually editing files for different environments. You deploy the same chart, but you feed it different parameters for dev, or staging, or prod.
Okay. And how does that help with those tricky dependencies you mentioned? Does it simplify managing, say, a web app and its database together?
It definitely helps. Helm has a mechanism for defining dependencies between charts. So if your web app chart needs a database chart, you can declare that. Helm can then help manage deploying them together in the right order. It abstracts away a lot of that complexity. Plus, it hugely promotes reusability. Well-written charts can be shared across teams, projects, even publicly. Think of the time savings and the consistency gain there.
So for you, the listener, especially if you're dealing with complex Kubernetes setups, what's the bottom line here? It sounds like Helm doesn't just make deployments simpler, it makes them faster, more reliable, and way easier to manage, even for complex apps. It standardizes things.
Exactly. It abstracts away a ton of that low-level complexity and shifts your focus from manually tweaking YAML to managing your application declaratively using templates.
Okay, let's really get into the weeds now with those three key components we mentioned. These are the core mechanics Helm uses. First up, values. What are values in the Helm world, and why are they so central?
So values are basically the settings you can customize in a Helm chart. They're typically defined with default settings in a file called values.yaml right inside the chart. You can think of them as the knobs and dials you can turn to tune a generic chart for your specific needs or your specific environment. And you do this without touching the chart's core logic.
Ah, okay. So that's what makes charts so flexible and reusable. You could have one standard Nginx chart, for example, but use values to deploy it with, say, one replica for dev and 10 for prod.
Precisely. Or different image tags, different resource limits, different service types, database passwords, anything the chart author exposes as a value. The values.yaml holds the defaults, like maybe replica count 1 or image.myapp.latest. But the real power is that you, when you install or upgrade, can override these defaults.
How do you do that override?
You can provide your own YAML file with your custom values, say my-prod-values.yaml, or very commonly in automation and CI/CD, you can set them directly on the command line using the set flag. It gives you a lot of flexibility in how you inject your configuration.
Right, like Helm install my app, chart repo me chart set, replica count 5, set service.type load balancer.
Yeah.
That seems really direct, especially for scripts.
Exactly. And these values, whether default or overridden, get fed into the templates, which we'll talk about next, to generate the actual Kubernetes YAML that gets applied. The big win here. No more manual YAML editing for different environments. Fewer errors, much more consistency. Deployments become repeatable and verifiable. And for more complex charts, Helm even supports schema validation, using values.schema.json to catch bad values early.
That schema validation sounds like a great guardrail. Okay, so values give us the control of the parameters. But how do those parameters actually shape the Kubernetes objects? That leads us nicely into the second piece, templates. If values are the knobs, what are templates?
Templates are really the engine, the core blueprint of your application inside the Helm chart. They live in the templates directory. And fundamentally, they are Kubernetes resource definitions, your deployments, services, config maps, etc., written in standard YAML. But here's the key. They're supercharged with the Go templating language. This means they're not static. They contain placeholders, like little variables that pull in the values we just discussed.
Got it. So this is how the deployment becomes dynamic. Instead of just static YAML files, the templates use the values to generate the specific YAML needed for this deployment.
Exactly that. So you might have a template file, let's say templates deployment.yaml. Inside, you'll see Kubernetes YAML structure, but also things like values.replica found or values.image.repository, values.image.tag. When you run Helm install or Helm upgrade, Helm's engine takes these template files, combines them with the final set of values, your overrides merged with defaults, and it renders them. It spits out the final Kubernetes manifest ready to be applied to the cluster.
So if my values.yaml or my set flag specified replica count, free pay, values.replica count, placeholder just gets replaced with 3 in the final output YAML.
Precisely. And it's more powerful than just simple substitution. Templates support logic, too. You can have conditionals, like if values.ingress.enable to only include an ingress resource if a certain value is true, or loops to create multiple similar resources based on a list in your values.
Wow, okay. That sounds incredibly powerful for handling complex scenarios without writing tons of repetitive YAML.
It is. It solves that massive problem of YAML duplication and makes configurations genuinely reusable and adaptable, reduces errors, speeds things up. It's really the core of Helm's power for building maintainable deployments.
Okay, this is making a lot of sense. We have values for customization, templates for dynamic generation. But what about managing the application after it's deployed? Upgrades, rollbacks. That brings us to the third key concept, the release lifecycle. What does Helm mean by a release?
Good question. In Helm terminology, a release is simply a running instance of a chart that you've deployed onto your Kubernetes cluster. The release lifecycle covers everything you do with that instance over time. It's the whole journey. Installing it initially, upgrading it to new versions or configurations, rolling back to a previous state if an upgrade causes problems, and finally uninstalling it when you don't need it anymore. And the really important part is that Helm tracks each release and keeps a history of its versions and the configurations used for each one.
Ah, so it's like version control, but for your deployed application on the cluster.
That's a great way to think about it. It brings structure and auditability to application management that was just missing before Helm. You install with a simple command, Helm install my release name, my chart. That creates release version 1. Then when you need to update, maybe change a value or use a newer chart version, you use Helm upgrade my release name, my chart sets from value, new value. Helm figures out the differences and applies only the changes needed. That becomes release version 2.
Okay, and the magic rollback. What if that upgrade, version 2, breaks something?
That's where the safety net comes in. If version 2 is unstable, you can just run Helm rollback my release name 1. Helm looks at its history, finds the configuration for version 1, and restores your application to that previous known good state. It's incredibly valuable for production stability.
That does sound like a lifesaver, so you don't have to manually undo changes or figure out what the old configuration was.
Exactly. And when you're totally done with the application instance, Helm uninstall my release name cleans everything up. It removes all the Kubernetes resources associated with that specific release, so you don't leave orphaned objects cluttering your cluster. You can always check the history of changes for any release using Helm history, my release name. It shows you each revision, when it happened, and its status.
Right, so the benefit seems crystal clear. It gives you this structured, versioned way to manage the entire lifecycle of your application on Kubernetes. It takes away a lot of the manual complexity and, frankly, the risk.
Absolutely. It makes managing deployments, handling updates, and recovering from failures much, much safer and more predictable. A real game changer for operations.
Okay, fantastic. Let's try and tie all three values, templates, release lifecycle together now. Can you walk us through a simple, concrete example? Maybe deploying something common like an Nginx web server?
Sure, let's do Nginx. So imagine you find a good Nginx chart, maybe from a trusted source like the Bitnami repository available on Artifact Hub. That chart will come packaged with a values.yaml file containing sensible defaults. Perhaps it sets replica count and image.repository.nginx, image.tag.latest. And inside its templates folder, it'll have YAML templates defining the necessary Kubernetes objects, probably a deployment, a service, maybe an ingress rule.
Okay, standard setup. But let's say for my production environment, I need higher availability. I want 3 Nginx pods, not just 1.
Simple. You use the values override mechanism. When you install, you'd run something like Helm install my prod Nginx bitnaming set replicount 3. Helm then takes the generic templates from the chart, looks at your override replicount 3 and uses defaults for everything else, and it renders the final Kubernetes manifest files. Specifically, the deployment template will now be rendered to request replicas. 3. Helm applies this to your cluster and Kubernetes spins up 3 Nginx pods.
Perfect. The template adapted using my value. The blueprint became real. Now, what if a security vulnerability is found in that latest Nginx image, and I need to update to version, say, 1.2, 1.4?
That's where the release lifecycle and upgrades come in. You'd run Helm, upgrade my prod Nginx, bitnaming Nginx, asset image.tag 1.2, 1.4. Helm compares this new desired state, new image tag, with the currently deployed release. It calculates the minimal changes needed in this case, updating the image tag within the deployment resource, and applies just that change. Kubernetes then performs a rolling update of your Nginx pods to the new version.
And the safety net. If 1.2, 1.4 introduces some weird bug.
You use the rollback feature. Let's say the upgrade was release version 2. If it's causing problems, you just run Helm, roll back my prod Nginx 1. Helm reverts the deployment back to the state it was in for release version 1 using the older image tag. Your application is back to stable. And finally, when you decommission this service, Helm and install my prod Nginx. Poof! All the resources Helm created for that release are gone.
It's really clear seeing it step by step like that. That whole process, install with customization, upgrade, rollback if needed, uninstall, feels so much smoother, more controlled, and, well, safer than manually editing and applying YAML files for every little change.
It really is. It empowers teams to manage applications confidently, knowing they have this structure and history behind them.
Okay, so let's quickly recap this deep dive then. Helm charts, really powered by these 3 pillars, values, templates, and the release lifecycle. They genuinely transform Kubernetes management. They take something that can feel really complex and error-prone, especially at scale, and turn it into a much more structured, repeatable, and resilient process.
Exactly. Values give you that crucial customization, letting one chart serve many purposes. Templates are the smart blueprints that generate the actual configs based on those values. And the release lifecycle gives you the versioning, the upgrade path, and that all-important rollback capability for safe management over time.
And together, they really hit those major pre-Helm pain points. The complexity, the manual configuration nightmare, the lack of versioning. They let you deploy, update, and manage apps much more efficiently and reliably.
Yeah, for anyone working seriously with Kubernetes today, Helm charts aren't just like a nice to have tool. They really represent a fundamental shift in how we package and manage applications in this ecosystem. They provide that structured, automated approach needed for everything from simple websites to complex microservices.
So here's a final thought for you, the listener, and maybe some next steps to really solidify this. If you haven't already, definitely install Helm. It's usually a very straightforward process. Then maybe spend some time browsing artifacthub.io. Just explore the charts available out there. It's pretty amazing what the community has built. And the best way to learn, pick a simple chart, maybe Redis or Postgres, or even just that Minjinx example we discussed. Try deploying it. Play around with overriding some values using set. Then try upgrading it. Maybe change the image tag. And definitely try rolling it back. Actually going through that install, upgrade, rollback, uninstall cycle yourself is where these concepts really click and you see the power firsthand. It's a great way to empower your own Kubernetes journey.